from Labellerr. We are SaaS-based tool to help enterprises scaling up their AI ML operation. We help them at with their various stages of their AI journey, like data preparation, annotation, model training, model building, deployment, and overall MLOps. Now we are in discussion with Jamie. Jamie is a VP of product at Astraea. Ask. So in most of the cases in different sectors, means people using AI as a tool of automation or some process improvement. So how AI or machine learning help in your case with your product? What value your client are getting from when you put AI in this all this imagery?
Yeah, I think that's an interesting question, and it's a philosophically we take a slightly different approach. Our experience is that most companies don't intrinsically care about AI and certainly not about satellite imagery. What they need are answers to important questions, and so the challenge with this is often that these answers aren't aggregated together in a uniform way, or that they require a lot of work to extract them out of images or out of multiple sources of data. And so our goal is to start with our clients and work with them to address the key questions that they have. And then we look to find a straightforward solution to that problem and answer it as quickly as possible. And then over time, we can use AI to automate those processes in a way that saves them money and saves them time. The time from the customer's perspective is typically about how fast we can get the answer out after the data are collected. And so from our perspective, AI reduces the cost of executing the answer to a question, and it increases the response time, or excuse me, decreases the response time, but increases the value to the customer by being faster.
Right. So in complete AI dev cycle, as a product guy, how you comes to the picture with the engineering team, data science team, and who initiate a product enhancement and how it will work. What is the workflow in your organization?
Yeah, that's a really excellent question. And one thing I can say is that I've been in the business of building machine learning and AI tools for a long time. And it's interesting as you work with software developers, different software developers understand this at different levels. And I'm lucky at Astraea, we're a small team, but the software development team really understands and gets what AI is and how data scientists work. And so one thing that's kind of funny is software developers often have a mentality that you want to make the tool as easy to use for the least common denominator when it comes to their user base. And what's interesting about data scientists is they have an extraordinarily high tolerance for pain. And what I mean by that is that they're not used to having tools that work seamlessly, and they're used to having to kludge things together to get their initial model to work, because they're always breaking new ground. And so working with data scientists is actually very different than most other software tools, because these users have a lot of abilities that most users don't have when it comes to moving data around or munging data or things like that. But they also have a deep appreciation when you make something that they usually spend a lot of time fussing with easier. So I think that what makes it interesting at Astraea is, as I said, our lead software engineer has the deep understanding of AI. And so we're building tools like clipping tools that make it much easier for a data scientist to just come in and say, I just want this little area out of this image, out of the stack of images, and to just process 100 images at a clip, get those clippings, and then use those in his ML workflow. Another example of some functionalities that we've focused on are things like chipping algorithms. If you want to build object detection tools, you want to build chips of images around the objects that you want to detect. And so we've built a chipping tools that support a whole bunch of different strategies, depending on what kind of data you're looking at. And so it's what I think is kind of unique, and or not necessarily unique, but certainly more rare, is finding software development teams that sort of intrinsically understand the domain that their data scientist users are working in. And so that's a foundation that we're building on, and that I think is really valuable. But to answer your question about flow and process, what we're doing is we work with our data science team, and they often lead the demand side of what we're trying to do. So we'll reach out and we'll have a customer come in, and they'll need to understand the impact of a conservation effort, for example. And our data science team will examine that and try to figure out what data we need to do that. And then they'll say, hey, Jamie, we need data like this, or in this organization, or we need the ability to click these data. And then we'll work with a software engineering team to devise a way to do that. And we prioritize that work in conjunction with the prioritization of our software platform. In a process ways, it actually creates more complexity for me, because I've got both the backend tools that we're building for our data scientists going at the same time as building our platform itself. And so, the trick is finding the sweet spot of the things that support both of those things simultaneously and pushing those forward first.
Right. So yeah, I mean, in most of the team that I talk, the data science team, they say that at the prototyping, at the experimentation level, things are pretty easy, and they don't face so much challenges. But when they're going to production level, then they are going scaling up. Then there's a whole lot of different ballgame. So how you tackle those kind of challenges as a product guy? How you kind of orchestrate your overall team?
Yeah, it's kind of funny. I came into Astraea after it had been in existence for a couple of years, and the team that was there prior to me always had a very large scale perspective on the work they were doing. And so they were always building tools and capabilities that could scale to a global level. As an example of one of those things, we have an open source package called raster frames. And raster frames is designed to make imagery data a first-class object in Spark. And Spark is a distributed compute paradigm. And so the idea was make it easier to process imagery at scale using Spark. And so that was the mentality of the company when I arrived, and that ethos has remained. But what's interesting is actually, in many cases, we're actually finding ways to scale down, because we have to scale down to solve small problems first at a local level, and then scale up to solve them more globally. And actually, that's been kind of a funny challenge in a way. Is when we start with this big scale stuff, it's actually harder for companies and organizations to start at that level. They typically want to start small and do pilot projects and some of the stuff that doesn't scale down as easily as it does scale up for us. But yeah, the main, but acknowledging that these data are big and heavy, and building out an infrastructure from the very beginning to handle that has been sort of the ethos of the company. So everything we do is backed by Kubernetes, and so we can easily scale up our clusters, and we can do horizontal scaling very fast. And we set out to be cloud native, so everything we've done leverages AWS or other cloud technologies. We're actually cloud agnostic because we do use Kubernetes, but we set out to leverage those tools from the get-go. Another example is our ability to render images using serverless compute. And so using Spark to do distributed compute is one paradigm of computing large scale data, and serverless compute is sort of the opposite end of that. And so we've started using serverless compute wherever we can, because it's so fast and so affordable. It makes it easier for us to deliver applications quickly. So the example is these clipping services that I mentioned. Those are available through using Amazon Lambdas on the back end. And so that's how we can process those images very quickly, and we expose that as a service, and our data science team just hits that service, and boom, they get the data the way they want it. And so we're working on building more and more of those kinds of services so that data scientists who use our platform feel that joy.
Right. You mentioned that you have a great software development team and also the data science team, but still there's even the best of the team, they face issue with the current tool available in the market to develop the AI. So what's exactly their pain point that you face in your AI development cycle? That you feel that there's some you feel kind of you stuck at some point of time that this tool is not working properly and they don't talk to each other. There's so many open source, so many module are developing at different platforms. So how you can collaborate all those stuff and stitch them together?
Yeah, it's an interesting question. It's a simple thing, but it's also a really complex problem. The variety of data that we need to be able to process actually poses a pretty interesting challenge of and just overall quality of data that you very commonly find. When you order data from a data provider like a satellite imagery company, they tend to deliver that data in a standardized way with the metadata that you can account for. So if you work with many satellite providers, you have to build a workflow for each one of them to ingest each of their data. But then if you go to an organization that's been collecting data for a long period of time, using drones and iPhones and satellites and anything else, the data comes in just a tremendous variety. And almost never do we find the date and time of an image properly annotated in the metadata of a geotiff. And so, using that in AI actually becomes really challenging, because if you don't know when the image was taken, or, it's a huge question mark. It makes it hard to search for it and catalog it and things like that. So that's actually, it's a huge challenge for us, is finding ways to render arbitrary data. And when I say render arbitrary data, if you just send me a geotiff, even if the coordinates are in it, and even if you have the date and time, the next question is, what are the bands and where are the bands placed? Sometimes you get images where the bands are in red, green, blue order, but other times they do it in frequency order. So you get blue, green, red, near infrared. And if you have hyperspectral or multispectral data, where are the definitions for all of that stuff, and how do you keep all that aligned? And then keeping track of that, it gets complex. And so that's been a challenge. Actually, probably one of the most frustrating challenges our team has dealt with is building an infrastructure that helps our customers bring in data, existing data. And like I said, when we work with our providers, we know what we're getting and we know how to deal with it. But when we work with existing data and archive data, it gets really tricky. So that's been a real challenge for us.
Yeah, means you are talking about that you have put in lots of data. So in what format these data generally come from? It's an image format like PNG or JPEG or something like that. And collecting such a large volume, I hope monthly basis, you'll be collecting all those things. And then, feed it to your AI model. How this overall operation works out. So feeding lots of data of continuous manner.
Yeah. So the core of our platform is our catalog. So Earth on Demand's catalog is a stack-based catalog, which is the spatial temporal asset catalog, which is a standard that's been emerging in the geospatial field. And so the first step in everything we've been doing is to catalog all the data that we use. And then we built workflows using some of the workflow engines in Kubernetes. And these workflows allow us to automatically run an analytic and send it through a pipeline. And it allows the sort of conditional, conditional modality. So, you can run it through, and if the imagery is there, and if the imagery isn't covered with clouds, then you can execute the model, and then you can run the model, and then you can send that a labeling team for validation, and they can validate that model. And if they reject it, then you can use them to create the data by hand or something like that. So there's a lot of those flows of working the data through, and then combining automation with human intelligence tasks and human intelligence teams. The sort of categorically across the industry, another big challenge that's faced is the lack of label training data. And I'm guessing that Labellerr is well aware of that challenge. But being able to leverage labeling teams and make them really, really efficient is part of the solution to this problem. And so, we're building workflows to pipe each stage of the process to the next stage, and sometimes that next stage is a human stage. And so that's been sort of one of the models we've used to accelerate our development, as well as build these production workflows. And at the end of all of these, we publish data back to our collection, to collections in our catalog, but we also expose APIs. And so our customers can actually access data via API, or we can push it to them through some sort of notification, or we can build an app for them if they need. So we sort of, just depending on who our customer is and what their needs and their internal abilities are, we can provide the data in any number of ways to support them. And some of our customers actually get like a PDF report because that's what they need.
Right. You cover all of those process, and you explain it all. So it was really insightful. The challenges that you are overcoming is a process. I'm thinking it's best way that you can manage it. So last thing that I asked everyone question is that how you see in your space in next coming 5 years AI adoption would be like.
Well, I was looking at my Slack feed this morning, and one of the articles was a listing of how many satellites are on orbit today, and it's like 7,000 some or something like that. That number is going to go through the roof. The accessibility of space is making the amount of data we can collect just continue to grow exponentially. It's been growing exponentially for years, but it's continuing to be exponential growth. And I forget, I think someone told me the other day that there was a statistic that it would take something like 7 million people to process the imagery collected by satellites in one day.
Right.
So obviously that's not going to work, right? Like, we're just not going to apply that level of work to the data that's coming down. So the only solution is to automatically process these things, and to use them to improve the AI to become more and more reliable, and to continue to answer these questions. So I think there is huge investment, obviously, globally in this, and that is going to lead to more data. More data is going to demand more AI to make use of it, but it's also going to create a very competitive market, and the price of imagery and the price of data is going to come down. Right. Just looking at satellite imagery, when I started working at Astraea just 2 years ago, a tasked high-resolution imagery usually started over $300 to $400, but easily was up into the $3,000 to $10,000 range if you needed something really, really high resolution, like a 30 or 40 centimeter image, and you need it soon. You could easily spend $3,000 to $10,000 on a single image. Today, we can task an image in a few days' time for $200. And that price, that just changes the game, because now it's cheaper to take an image than it is to send someone out to a site to see what's going on. In addition to that, the frequency of coverage is going much higher. You can get an image of any spot on the earth multiple times a day at this point. And it used to be that there was only one provider that had daily coverage of the whole globe, but that's actually changing. And there's other providers who can capture an image anywhere on the globe multiple times a day. And that's also changing the game. Another interesting development is, we're seeing creative platforms. There are companies that are launching balloons, and from these balloons, they're capturing imagery data and other data as well. Some of them are so high up that they can actually, maintain persistent surveillance over huge areas, like regions of the US. And so just because of their vantage point, they can get a 2-minute revisit anywhere in the state of California for hours on end or days on end. And so, the level of surveillance is growing, and that changes how, what we can use these things for. So now it's much more practical to use balloon imagery to detect the ignition of forest fires, which is a big problem here in the US, because we can look over large swaths of area on a regular basis. And our geospatial satellites do that as well. So now we have multiple platforms collecting large areas all the time. I think the persistence is going to grow, and that we're going to see things more and more like video in space almost.
Right. So what would according to you, the most exciting use case that can be solved if we get to the level where the images are very cheap, that we cannot do right now, but in future you see that those are the most exciting use cases?
My tilt on this is always ecological perspective. And I think that better understanding our Earth and the impacts that we have on the Earth and how we can improve that and ensure that we're improving it is perhaps the most important thing we can do with these data. So if we can fuel the ESG movement in finance, if we can provide tools to help people reforest after forest fires, and to measure carbon output and to detect ecological hazards, I think that remote sensing is a key part of preserving and saving our Earth. And it's hard to understate that, and it's hard to think of something more exciting in my book. It's not it's not a sexy new app or a simple little thing, but I do think that AI is a key part of preserving and protecting our environment, and that to me is really exciting.
Oh, nice. And see you putting your time and talk to us and really share your story so far. It's been really insightful. Thank you for your time, Jamie. Thank you.
You're more than welcome.
Yep.
You're welcome.